today unit 2. You can refer Samuel Leo book, page number 141 to 161. Okay, in that scattering matrix is not there, although some of the concept, or you can say a few concept which is given for the S scattering matrix as parameter as well. But I'll discuss in brief the scattering matrix, because we are going to discuss the scattering matrix for each and every microwave devices which is there in our syllabus. So first one is a scattering matrix, and the second topic, which we have a passive microwave devices, like we have a microwave hybrid circuit. So we have terminator, actuator, phase shifter, a directional coupler, two-hole directional coupler, S matrix of a directional coupler, hybrid coupler. Then we have microwave propagation in ferrite, like we have a isolator, circulator, and it is given as S parameter analysis for all components. So whatever the component we have, we will see the S parameter for all. Although you will not get analysis of S parameter in the Samuel Leo book, a few of them it is given, but not for all. Okay, some of them is directly written the S parameters. So I'll discuss the S parameter for all. Okay, in detail. Now we are going to start a scattering matrix. First topic is scattering matrix. Before going to the scattering matrix, I would like to tell you that we are having different microwave hybrid components. Like we have a E plane T, that is T junctions, H plane T, magic T. Okay, then we have a hybrid ring, directional coupler, okay, circulator. So all these we will discuss one by one in detail after completing the scattering matrix. Okay. So basically, microwave circuit ordinarily consists of several micro devices that is connected in some way to achieve the desired transmission of a microwave signal. So we have a source, and we have a destination. In between, we have a microwave components that is there connected in some fashion. Okay, and that component we are going to study. So how these components are connected, and what are the parameters, and how this scattering matrix, how these micro devices can be designed. Okay, so what are the parameters for them, we are going to discuss. Okay, the interconnection of two or more micro devices may be regarded as microwave junction. So we are also see the microwave junctions maybe will have another terminal, another port, and this is called as a junction. This is called as a junction. So we will see that microwave junctions also, how the junctions is look alike. You can see in E plane and H plane T, we have a junction here. We have a junction here. Okay, so we will see these junctions also, how this can be designed. Okay, so microwave junction conclude waveguide T's. Okay, as E plane T, H plane T, magic T, hybrid ring. Hybrid ring is also called the rat race T. Okay, so rat race circuit, directional coupler, circulator. Okay, so we will see one by one in detail. Okay. Now we are going to start the scattering matrix. Before going to the scattering matrix, can we have some uh, concept about two-port network? So it's also scattering matrix, scattering parameter can be analyzed using two-port network. But what is two-port network? So from network theory, a two-port devices can be described by number of parameters such as H parameter, Y parameter, Z parameter, ABCD parameters, like we have seen already in the network theory. So these parameters can be taken from the two-port devices, like we have a input and we have a output from this side. So suppose we apply input from this side, we are taking output from this side, and we have a device which is connected here. So that is having a two-port, this side and this side. Okay. So now we have a voltage. We are just taking the network theory concept. So we are applying the first terminal. This is the port 1. Okay, and this is port 2. So port 1 comprises the voltage which is called V1, and the current which is going inside is called I1, and port 2 comprises of voltage V2. Okay, and the current which is going inside is I2. Now you will say, sir, why these two current are coming inside? So one can say the current will be come outside also. Okay, that will be reflected. So we will see one by one in detail. Okay, now we have a H parameter. So H parameter can be represented in this form. So V1 I2, H11, H12, H21, H22, and I1 V2. So the equation will come like V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. We can find H11, H12, H21, and H22 by taking the one of the parameters, voltage and current, taking as 0. Suppose we want to take H11, so H11 comes out to be V1 by I1 by taking into consideration that V2 is equal to 0. So one can say it can be short circuit, it can be open circuit. So if you say V2 is equal to 0, that means this should be short circuited. So if you short circuit this terminal, you can find out H11 parameter. Similarly, if you want to have this H12, so if you want to find H12 should be equal to V1 upon V2, V1 upon V2 by taking care that I1 should be equal to 0. So if you substitute this, whatever I'm saying, if you substitute in this equation, you will get these two. So if I1 equal to 0, that means this terminal should be open. Okay, this should be open circuited. So we are just considering that H parameter, Y parameter, Z and ABCD, whatever we are considering, whatever we are going to find out. So that will be based on the open circuit and short circuit concept. So by taking port 1 short circuited, port 1 open circuited, port 2 short circuited, port 2 open circuited, depends on the combination of that, we can find out these parameters. So similarly, we have a Y parameter that is called admittance, and the Z parameter, ABCD parameter, we can find out, we have the equations. So all these deal with the voltage and current. Now we are having the microwave devices, and microwave devices deals with the wave. Okay, so why it deals with the wave, we will see. Okay, so for these network parameter related total voltage and total current, so total voltage and total current at each of the two ports. For instance, if you want to find out V1, H11, H12, we can have the short circuited and open circuit. Short circuit means port 2 will be short circuited. Port 2 will be short circuited, and this will be port 1 will be open circuited. That is discussed here only. Similarly, you can find for Y parameter also, Y11, Y12, Y21, Y22, you can find it out. And this can be represented in matrix form here in this way. So now, so network parameter exists so far. We have H parameter, Y, Z, and ABCD. So these parameters are derived from terminal voltage and current measurement. So we are dealing with the voltage and current measurement. So you can see here also we are dealing with the voltage as well as current. Okay, voltage and current, voltage and current, voltage and current measurement. So now we are going to deal with the wave in the S parameter. So there is a we will see. Okay, so now we have they require application of short circuit and open circuit termination for evaluation. So for evaluation of these parameters, we need short circuited as well as open circuited. Okay. So now what is shortcomings? Okay, so voltage and current are distributed at and vary with their positions in microwave frequencies. So voltage and current are distributed parameter, that is not lumped. Okay, so in the microwave circuit, at microwave frequencies, that is the line which you are taking or devices which you are taking, that is a distributed parameter that consists of a distributed parameter. So that vary with their positions. Okay. So active devices becomes unstable. So whatever the devices which we are using, that is active devices, and that becomes unstable when terminated with open and short circuited at high frequency. So at high frequency, if you are going with the open circuited or short circuited, your devices, that is active devices, your devices will become unstable. So we cannot deal with, we cannot go for open circuit or short circuited kind of thing. Okay. So effect of interconnecting leads between test equipment, okay, and the devices under test becomes critical at high frequency because of an instability. Because of instability, it becomes critical at high frequency. So interconnecting lead means the device under test, that is called interconnecting leads. Okay, so that is connected with these devices. So test equipment is nothing but input devices which we are using, or at the output which we are connecting, at the output put we are connecting, and the device under test is nothing but the devices which we are using for the interconnecting purposes. Okay. What is happening? Am I audible?
Audible, sir.
Yeah, okay. Okay. So there was interruption. Okay. Now, our wide spectrum of frequency. So a wide spectrum means we are using with the we are dealing with a gigahertz frequency. Okay. So that will be obviously wide spectrum. The bandwidth will be high. So over wide spectrum, it is difficult to achieve short or open circuited. Okay. So now you understand we are having some shortcomings in the that these parameters, the parameters which we have already in the network theory. So now what is the solution for this? The solution for this is a scattering parameter. Okay, that is also called as a S parameter. Now its calculation is based on forward and backward traveling waves on the terminal transmission line. So like we have, see this interconnecting lead is also called as a transmission line. So now its calculation is based on forward. Forward means incident. So suppose we have a two-port network. So this is nothing but the forward, which is called incident, and this is called backward, which is called reflected. This is also incident, this is reflected. So it depends on the incident and reflected wave, traveling waves on the terminal of the transmission line or port of the transmission line. So the directly measurable quantities are amplitude and phase of the incident and reflected wave. So directly measurable quantity here is amplitude and phase. We are dealing with amplitude as well as phase of the line, transmission line. Okay, so we are going to discuss the amplitude and phase of this transmission line, okay, of this micro devices. So now the question again we are having, the question says if the frequency are in microwave range, okay, if the frequency are in microwave range, so we cannot use H, Y, Z parameters. Why so? So why so means these are the following reasons which is given here. Okay, so following reason which I discussed earlier also. So the equipment is not readily available to measure total voltage or total current at the port of the network. So equipments are not readily available at that much of high frequency. At that micro frequency, we cannot measure the voltage as well as current because those of the distributed parameter. Okay, so now the short or open circuit are difficult to achieve over a broadband frequencies. So at high these frequencies, short or open circuited are difficult to achieve, and active devices become unstable. So such as power transistor and tunnel diode frequently will not be have stability for a short or open circuit. So these are the devices which is there for this. So example which is taken here. So active devices like we have power transistor, tunnel diode. These are the micro devices. So which cannot be stable at short circuit or open. If you do, so you will not get a stability in these devices. Okay. So these are the reasons. That's why we are not using H, Y, Z parameters in the at micro frequencies. Okay. So now, consequently, we have some new method of characterization is needed to overcome these problems. So these are the problems. So some new method of characterization is used that is called S parameters. The logical variable to use the micro frequencies to use at the micro frequencies are traveling waves rather than total voltage and total current. So rather than total voltage and total current, we are using the traveling waves. Okay, traveling waves, and we are going to calculate the amplitude as well as phase of that wave. Okay, so these are S parameters which is expressed here. So now we have the two port. So first port is represented here, and the second port which is given. So we are just applying some voltage. We are applying some voltage, and the impedance which is given here. So there will be some current which is going. So the voltage wave which is traveling, and as well as current which is traveling inside this. And in this two-port network, the some of the voltage will be, some of the voltage and some of the current will be transmitted. Some of the voltage and current will be transmitted, and it will be going to the load side. But some of them will be reflected back also. So some of them will be reflected and reflected back through this port only, another side. And again, we are having the voltage which is coming here. So some of them will be dissipated at this load, and again, some of the voltage will coming inside this. So it depends on these combinations, this incident and reflected wave. We have different parameters which is shown here. So S11, S12, S21, and S22. Okay. So what is S11, S12, S21, S22? Why so? Why it is represented like this? What is the meaning of S11? What is the meaning of S12, S21, and meaning of S22? I'll explain these things. Okay. So depends on these combinations, depends on these. Okay, so it will be represented like this. We have a B1 which is equal to S11A1 plus S12A2, and similarly we have B2 which is equal to S21A1 plus S22A2. So in this way it is represented, and some of the time it is also called as a output. Okay, so it is also reflected wave is also called as output. B1 is the output, B2 is the output, and A1, A2 is the incident or input, which is called as input. Okay, so you can say this is the incident from port 1, and this is the incident from port 2. So incident is nothing but input, and this is the reflected, and this is also the reflected. So reflected is also called as the output side. So it will be, if in matrix form, if you represent, so this will be B1, B2, and for the 2 cross 2 matrix, it will become S11, S12, and we will get A1, A2. So first equation will be B1 is equal to S11, A1, S12, A2. Okay, so row will be multiplied with the column. Now we have S21, the second matrix, B2 is equal to S21, A1, and we have S22, A2. So this is the representation which is given in a matrix form. Okay. Similarly, we can go for multi-port also, M-port combinations also. We will deal with M-port combination also. If we have different ports, then what we will do, we will see. Okay. So this is the matrix representation for these parameters. So what are the advantage of S parameters? So at advantage of S parameters, matched load are used for terminating port. So if the port is terminating, we will use the match port to have the maximum power transfer that is taken place. So if the load is matched, then that means the power will be, maximum power will be transmitted, which will be inductive or capacitive effect. So which basically, if you match your load, and if you match your load at the port, terminating port, so your inductive or capacitive effect will be eliminated, and due to this, your maximum power will be transferred to that port. Okay, so it is easy to measure in S parameter, easy to measure the power at high frequency than the electrical parameters. Electrical parameter, like we have a voltage or current. So okay, so it is easy to measure the power. Okay. Now resistive termination with high stability. So resistive termination with high stability. So we will have Z0, which is equal to ZL, that will be matched. So resistive termination. So load will be terminated with the characteristic impedance. So that will give you the higher stability. Okay. Different devices can be measured at the same setup. So different devices means you are having the setup. So you are having the setup, the network, and at the port we are just changing the devices. So we are just changing the devices. So at the same setup, we can change the different, we can take different type of devices and we can measure. Okay, so that is easy in the S parameter analysis. So what is the disadvantage for this? So disadvantage is it is useful in frequency domain analysis and not in time domain analysis. So what about the voltage current equations that we are using, voltage and current equation, that is all the parameter which is used, that is in time domain analysis. In the network theory, we are dealing with the time domain analysis and we use the time domain. So in the S parameter analysis, we are having the frequency domain. Although we can convert from time domain to the frequency domain, but conversion will leads to some error. Okay, so conversion between time domain and frequency domain introduces error. So we cannot frequently use the time domain to frequency domain. If we convert, we need more care. Okay, so although we are having the conversion of S parameter to the ABCD parameters, so we can convert from frequency domain to time domain, but that leads to error. Okay, so we need to take more care of that while conversion. Now, most of the silicon load are non-linear. So moreover, most of the digital circuit operates using voltage threshold. So these applications require time domain analysis, which is not possible in S parameters. So most of the digital circuit operate with the voltage threshold. So digital circuit which we have, so that is deal with the voltage and current. Okay, equation. I'm not talking about microwave frequency, just talking about general digital circuit. So general digital circuit and silicon load, which is there, silicons frequently used in the digital circuit, which is non-linear. That load is non-linear. and this S parameter cannot be used there. Okay, cannot be used there because most of these are digital circuit are in the analyzed using in the time domain. So we cannot use this as parameter generally for the all digital circuits. So we generally deal with the microwave frequencies. We use as parameter at micro frequencies. Now we're going to discuss the static matrix. Okay, so for two-port network, if the power is applied at one port, so if you apply the power at one port, so power means we are having the voltage, we are having the impedance, we're just applying some power at one of the port. So most of the power escapes from other port. So most of the power escapes from other port, while some of it reflects back to the some port. So most of the power will be reflect most of the power will be escaped from the other port, and some of them will be reflected back. Okay, so if you apply power from one port. Now, if the source is applied at opposite port, okay, source is applied at opposite port, another two combination are to be considered. So one of the port is source and another is load. So your combination will be 2 cross 2. That means 4 combination will be there. So for a 2-port network, 2 cross 2, 4 combination are likely to occur. Okay. So what are the 4 combination? That is nothing but S11, S12, S21, S22. These are the 4 combinations. The traveling wave with associated power when scattered out through the port. So when the traveling wave that is having some power associated with some power, and when they scatter out from the port, the microwave junction can be defined. Okay, so when they scatter from the port, so there is a junction. That junction will be formed, and that junction can be defined as a S parameter or scattering parameter. So which are represented in a matrix form called as a scattering matrix. Okay, that can be represented in a matrix form, and that matrix can be called as a scattering matrix S12, S21, S22. Okay, it is a square matrix which gives. So keep in mind always scattering matrix is a square matrix always, and the property of a scattering matrix also says the scattering matrix is a square matrix. So square matrix having a dimension n cross n. So if you are having the n ports, n number of ports, that means a square matrix that will be the dimension of n cross n. So scattering matrix is always, it depends on the number of port that is used in the interconnection. Okay, at the junction. So which gives all the combination of power relationship between the various input and output ports of a microwave junction. So that will give you all the combinations, or you can say all the combination of power relationship. So S11, S12, S21, S22, that will give you the power relationship between the various input and output ports of at the microwave junctions. So element of this matrix is called as scattering coefficient, and this is called a scattering parameter. So these are the scattering coefficient, scattering coefficient. So what are the name of these scattering coefficient? We will see. Okay. Now I'll take one figure. Okay. So in this, we just take 2-port network. This is called 2-port network. So in this 2-port network, we are having the first port this side and the second port this side. Okay. So this port, this is also called as a port. If you want, you can give as a name as a port I and port J. We are just checking. Okay. Can we take as a port 2 only? Okay. Port 1 and port 2. Okay. No worries. You want, you can take I, J, K, L, because we are dealing with the 2-port. That's why I have taken port 1 and port 2. Okay, you can name it as a different port also for M port. So now we have a 2-port and port 1 and port 2. So let us consider a voltage wave which is coming from this side, and that is called as a V1 plus. Okay, so plus means incident wave. Okay, and the current which is going, that is called I1 plus, and there will be a reflected wave. So that reflected wave is called V1 minus, and the current which is coming out, that is called I1 minus. Okay. Similarly, we are taking some voltage. That voltage is called as a V2 plus. that is going incident, and current which is going is I2 plus. Similarly, this is called V2 minus, and the current which is going called I2 minus. Now, if we want to calculate power wave, if we want to calculate power wave injected at port 1, so this is called as a, sorry, this is called as a A1 square, and it is represented as B1 plus whole square divided by Z naught. So about the power which is called as a V square by R. So that is represented, Z naught is equal to characteristic impedance of the two-port network. So V1 plus S square divided by Z naught. Similarly, if you want to check the power wave, okay, reflected at port 1 or reflected from 1 minute, reflected from port 1. So that is represented as B1 square, which is called as a B1 minus square divided by Z naught. Similarly, you can find for, similarly, you can find for, port 2 also. Okay. So you can find for port 2 also, similar way. That will be V2 plus square divided by Z naught and V2 minus square divided by Z naught. So now if we consider this two-port network and we take it as a power which is coming as a A1 and reflected as a B1, okay, incident is A1 and which is going as a B1 this side, okay. So A2 the wave which is going inside, and similarly B2 it is coming outside, reflected wave. So this from A1 to B1 that will be represented as S11. I'll let you know what is this, and this is represented S21, and this is represented as S22, and this one is represented S12. Okay, so what is this? Okay, we will see. That is our concern. Okay, so now if you go through the equations which I have just described, that B1 is equal to S11 A1 plus S12 A2, and B2 is equal to S21 A1 plus S22 A2. So you can see here, if you want to calculate B1, so at this point, at this port 1, this side, you can see S11 is coming multiplied with the A1 and it is coming to this one. So we can say S11 A1. Similarly, we can say S12 which is coming with the A2. So A2 which is coming here, so A2 S12 A2. Similarly, if you want to calculate for B2, so B2 will be your B2 will be S21 A1 which is coming incident from this side. So S21 A1, and similarly we have S22 A2, okay, from this side S22 A2. So that will be represented in this form. Now if we want to have S11, so S11 will comes out to be B1 by A1 by taking care that A2 should be equal to 0. You can see this equation number 1, equation number 2. So if you want to calculate S11, I would have taken A2 is equal to 0. We cannot take S12 0 or S22, any of the S parameter, we cannot take 0. We can take A1, A2 as a 0. So we, at that time, we cannot apply this one, A2. We can take this A2 is equal to 0. That means that this port 2 is matched. This port 2 is matched terminated. So matched terminated means what? Match terminated. So that means if this is matched, all the wave which is coming, that will be dissipated here. That is a value, and that will be dissipated at this. So no wave is coming this side. So at that time we can say the wave if we just represent or in the statement form, so we can say this B1 is called reflected wave. You can say B1 is nothing but reflected. This is incident, this is incident, and this is reflected. Similarly, this is incident, this is reflected. So now this is called as a reflected wave at port 1 divided by, this is nothing but B1, and A1 is nothing but incident. So incident wave at port 1. Okay, at port 1. Incident wave at port 1. Okay. By taking care that when port 2 is matched, terminated, matched, terminated. Okay. Similarly, we can find out for S11. So we can find out for S12 also. So what is the value of S12? At the time of S12, A1 will be 0. So that will be S12 is equal to B1 by A2. So S12 will be written as S12 will be written as B2 by B1 by A2, na B1 by A2. I'm sorry. B1 upon A2. B1 by A2. So that means at that time A1 should be equal to 0. So that is port 1 should be matched terminated. So this means this is called reflected wave at port 1 divided by incident wave at port 2, and taking care that when port 1 is matched terminated. Similarly, I can go for S21, and similarly we can go for S22. So S21 is nothing but, you can have the equation and you can see S21 is nothing but B2 by A1 by taking care that. So B2 by A1 by taking care that A2 should be equal to 0. Okay. And similarly, if you want for S22, so S22 is B2 by A2 by taking care that A1 equal to 0. So similarly, you can write it down. This is B2. So what is this B2 here? Okay. What is a B2 here? So now S21, I'm talking about S21. So S21, you can see here, this S21 is nothing but we are having B2 divided by A1. Okay, B2 divided by A1. So this B2 divided by A1. Okay, so I'm talking about S21, no? S21 or S12. S12. No. What I have written S11, S22. I have discussed. What B1 divided by A2. B1 divided by A2. Okay. Okay, I have written S12, na S12 B1 divided by A2. So this B1 is nothing but, this B1 is called as a not reflected wave here. This B1 is nothing but transmitted wave at port 1. This P1, if you see this B1, if you consider that S12, if you go for S12, so S12, if you talk about, so you are taking incident from this side, you're taking incident from this side and going out from this side. So this is called as a transmitted wave. This B1 is nothing but transmitted. See, input is coming from this side. Input is coming from this side and it is going this way. So this is not reflected here. This is transmitted. Okay. This is incident which is coming from this side, and it is going in this way. So B1 is not always reflected. This at this time it will be transmitted. So we can just correct here. So this is called transmitted wave. This is called transmitted wave. This is called transmitted wave. Now we can have S21. So if we talk about S21, so at this time, we can have incident as A1 and B2 is going as a transmitted. At this time, it is not reflected. So it is going incident. It is going transmitted. So S21 incident at this time A1, it is going transmitted. So we can just name as a transmitted wave at port 2 divided by incident wave at port 1 when port 2 is matched terminated. Okay. Similarly, if you go for S22, so S22 is nothing but B2 divided by A2. So S22 is nothing but B2 divided by A2. So S22 will be B2 divided by A2. So B2, your this B2, if you're talking about same port, no? Same port. I'm talking about same port. So this is incident, this is reflected. This is reflected. At same port, it is reflected. It is not transmitted. It is not coming from other port. It is coming from same port and reflected back. So this state, this is called as a B2 is called as a reflected wave. So you can say B2 is reflected wave, sorry, wave at port 2 divided by port 2 divided by, we can say this is called incident wave at port 1, and when port 2 is matched terminated. Okay. So now we can write. So now we can say this if you represent in a matrix form from equation 1 and 2. So equation 1 and 2, sorry, equation 1 and 2, if you write in a matrix form, so this can be written as a B1, B2, which is equal to S11, S12, S21, S22, and we have A1, A2. Okay, so you can write it down this way. Now we can have next slide, this one you can see. So in this we have taken the multiple ports, that is port starting from 1 to n. So number of port is 1, 2, 3, okay, 3, 4, 5 to n. This is the number of port, okay. So that means that number of port we have, and it is represented as ith line, that is called first line, second line, up to nth line. And in between any port, that is ith port, we are taking as a source. So at ith port, any one ith port, we are just connecting our input, or you can say connecting our source. Okay. So if we give the general statement, okay, so we can have some source which is connected through the ith line, and in that you can have AI, which is called incident wave, and BI is called reflected wave. So we have AI is called incident wave, and BI, which is called reflected wave. And we just write the source is connected through ith line. Source is connected through ith line. And if we want to give the relation between A1 and B1, if we want to give, if we want to give the relation between A1 and B1. So how we can relate A1 and B1? So let us consider A1 at port first line at port 1 and B1 is also at port 1, and we assuming
Sir,
that this port, yes,
sir, next class has started.
what is the time?
Sir, 324, 325.
Okay, okay. ठीक है. So I'll wrap up here. Okay, I'll stop here. So we'll discuss. Okay, we'll discuss from here in the next class. Okay.